Welcome to Darren's Maths Corner, and today we are going to have a look at the keys of a calculator. I've got my scientific calculator with me, which we will use. I'll certainly use this to go over the questions that we've got in the upcoming exercise. I've had this calculator for 20 years and it still works just well. It still works just as fine as it did when I first got this in 2005. So for now, let's just give you a bit of an intro and hang on, that's better. And then we'll be able to go through this exercise. So, to use your calculator most effectively, you must become familiar with the keys and their functions. Now, a calculator will come with a booklet, and that will tell you the order that the keys are used for each calculation. So, for example, to find the fourth power root of 5, you would have to do the following, which it does involve an inversion, but I don't have one. I don't have an invert button on this calculator. So in order to do that, you then that's going to be interesting. I've got to try and work out what I'd have to do with this calculator because I don't have an invert button, which is really rather interesting. Yeah, that's not what I'm after. I do want to be able to invert stuff on here. So in which case, I'm going to switch to my phone and see if I have an invert button on my calculator here as well. I've already got a function already. I already had a sum and so yeah, you'd end up doing that. You'd think. But I don't think that is the case. Let me just get rid of my history. Because I'm just trying to work out how would you invert a number on here. I mean, you get that on the phone's calculator. I've got an iPhone 16 Pro Max here. Which is all fine and dandy. But yeah, we just have to, those are the keys that you would require. 5 invert. Five. Unless it's that. But let's move on. There's some other keys that are useful on a calculator, which one of them is the memory keys. And let's see if you can use them correctly. So you've got Memory Plus, which I think gives you the memory to a positive number. M-, which does the exact opposite. Memory recall, to which if you want to add something and you want to restore something from memory, you'd be able to do that. And the min, I think that would be the memory invert, but then I think that's what it is. Typically what it is. And then you've got brackets, which, for example, there's an example that we've got there. Just out of interest though, I wonder what that would equate to. 6. That's 6. Okay. So that's what the example equates to. You just have to remember that that fraction is equal to 36 times 14 over 21 times 4. You do the brackets. Or 36 times 14 divided by 21 divided by 4. We'll double check that. So we know that the correct answer is 6. Let's see if both these examples come up with 6. Yeah, that one's 6. And 36 times 14 divided by 21 divided by 4. Yeah, 6. So they all of those are equal to 6. However, if you do the one that it's not, yeah, you get 96, which isn't the right answer. But then you've also got your clear keys as well, so you all will clear the calculator apart from the memories. The C or the CE buttons will correct an error entry. So if I switch to this calculator, I will show you what it does. So I'm going to put 6 plus 3. And then you've got that. So I've done 6 plus 3. But then I wanted to do but then I wanted to do 6 plus 2. So you could either use the backspace button on the calculator or the C, which will correct the error. And then you do all clear. So the next thing we want to look at in this case will be the exercise. Let's start with the following. So what I'll do is I'll put this into a calculator. Which will at first look at 386.9 divided by 32.87. That's the answer I've got. I shall put that on the screen as well. And we want to round that up to 1 decimal place, which will be that 7 there. So it's going to be 11 points. And if we look at the second decimal place and we find that it's greater than 5, so then we round the first one up to 8. The next one is 2,756 divided by, we have basically inverting the sum round. To which we get this, because we made it much bigger. Just remember, if you're dividing anything by a number less than 1, we are going to make the number bigger. And then we want the 3 significant figures, to which then we put in the zeros. And 73.9, because we'll just think of it in standard form. 73.9 rounded up, because it's greater than 5. And the first of those zeros then becomes a significant figure, because we're looking for 3. Yep, we're looking for 3 in this case. Or maybe not, because we're looking for 3 significant figures, so we're therefore looking at the 4th, and it then becomes that. 1's less than 5, so we round that down. I nearly rounded to only 2 significant figures, and the degree required was 3. Never mind. Next, we are looking at... Didn't realise you could do that. Look what I've done there. The square root of 75.9 over 10.9. I wonder what that would give me. Yeah. That's what the answer is. I shall write that down quickly. And then we're looking for 3 significant figures. So we'll do 2.6. That's 2 significant figures. And then we'll round the 3 up, because we've got then an 8 that follows from that. So then we have a round up. This one's going to be an interesting one. So we got 0.000356 times 385.7, which gives you that as an answer. I shall write that down as well, just in case we get blurred out. And we're looking for 3 decimal places, which are these 3. And we then focus on the 3 that's next to it. Now, because that's less than 5, we then round it down, and therefore it will stay as it is. Next, we want... Oh, this is going to be interesting. Oh, I've got it. I've sorted it out. Which is that. That's what we're trying to work out. And oh, look at this. Will the answer display on this slideshow be long enough to fit this in? We've got 10 decimal places, we're looking for 3. So we do 0.87, and because we look at the 5, and because it's equal to 5, we then round it up. We round up the 3. Next one is 1. So 1 over 0.0345. So I've got 2000 over 69. Let's see if I can convert that into decimal. I can. It's a recurring. So if you see the dot over the top, whoops, I didn't want to do that. If you look at the dot that's hovering over the top of that number, that indicates that it's a recurring digit. So we'll then just do 28.98, and then I'll just put 3 dots after that, so then you know that it's going to be recurring. And then we're looking for 3 significant figures in this as well. But we've got 28.9, to which then the 8 rounds up the 9. But then that 9, that then becomes 29. And I put the extra 0 in as well, just to have it indicate that it is to 3 significant figures. Next, 4.63 squared. We've put the 4.63 in brackets. That's what we've got there. And we again are requiring 3 significant figures. And the 3 is less than the 5. So then the number stays as is. This is an interesting one. Luckily there is no accuracy required, as you just type the number as is. 1/2. But what we've got here is 1/2 246.3 plus 1092.8 plus 376.4 plus 49.8. There's your answer over 20, and it's just that. And that's just it. The next one is 3 significant figures. That's three decimal places. So in brackets you put 51.7. This is doing Bibmus. Plus 63.2 plus 28.9 divided by, in more brackets, 71.6 plus 104, 104.2. That's what the answer is, just in fractions. So let's switch that. Oh dear. Turning up to 8179749716. And 3 decimal places, so it'd be these 3 that we pay focus on. And then we'll look at the 9 next to it and see that it is greater than 5, so we round the 7 up. The next one, again, doesn't require any accuracy. So we want then, in brackets, 12.7 squared plus 2 times 12.7 minus 15.3. Bearing in mind this is a bit miscalculated, so that's what we've got there. And that would be 171.39, yeah. Easy enough to be done because it is divisible, because yeah, you're just basically dividing it by 100. So I've got there. And the last one is the following. To 3 decimal places, 1.54 cubed plus 1.54 squared plus 1.54. That's what we've got there. And I should write that down, 7.563864. And again, we're looking at 3 decimal places. To which then we keep the 7 and the 5 and the 6. And because the 8 is higher than 5, because we're looking at the digit next to the 3, because that is greater than 5, we then round the 3 up to a 4. And that is the exercise of this video. But I hope you enjoyed this video. Don't forget to like, comment, share and subscribe. Thank you for watching, and I'll see you in the next video. Bye.